All right, guys, here's your helpful hint video for your derivative review worksheet for this week. All right, so on this one, I'm just going to go ahead and go through all the problems that I've assigned to you. So sit back and enjoy, or just look up the ones that you need. So in this problem, it says if y equals e to the x power times x minus 1, then y double prime equals what? All right, well, this looks to me, so we want to find the second derivative, and after we do that, we want to plug in 0. So to find the second derivative of this thing, the first thing I'm going to do is I'm going to apply the product rule. I've got e to the x being multiplied by x minus 1. So the product rule is blank times blank plus blank times blank. So the derivative of e to the x is just e to the x. And then we don't take the derivative of the second part. And then in the next one, we leave the first part the same, but we do take the derivative of the second part. Okay, so there's my first derivative. It's e to the x times x minus 1 plus e to the x. Now I need to find my second derivative, and I get this. It's the same exact thing I had before, right? So this whole answer gets repeated. The derivative of that's going to be e to the x times x minus 1 plus e to the x, and then we have this other e to the x here. So the derivative of this piece is all of this, and this e to the x just comes down. Okay. Once we have that, we just go ahead and plug in our 0. So that's e to the 0 times 0 minus 1 plus e to the 0 plus e to the 0. E to the 0 is 1. 0 minus 1 is negative 1. So this is negative 1 plus 1 plus 1. Those cancel. Final answer is 1. Okay? All right. Let's go ahead and continue the process here. What was our next question we need to do? I think it was 35 through 38 is next. So let's scroll down here. Ah, yes. We just did these types of questions on our last test. Or not our last test. Our last quiz. All right. So, when I see this, I don't see just a limit. I see the limit of a difference quotient, which means this is really a derivative. Therefore, the function we're finding the derivative at x equals 1, so I'm going to call that c equals 1 there. And then if we replace that with an x, drop out the h, that tells us our function that we're finding the derivative of. It's x to the 6th. And this limit of this thing is what would give us the derivative of f at that value of x. So I'm going to use my shortcut instead of finding the limit. F prime of x is 6x to the 5th power, and f prime of 1 would therefore be 6. Okay. All right, next question, 35, 36. All right. In this case, my c value is 8. My function would be, if I replace the 8 with an x and drop out the h, would be x, the cube root of x. All right, so first of all, I want to find the derivative of this thing, because that's what this thing represents. It represents the derivative of that function at 8. So before I do, I want to rewrite this function, though, as x to the 1/3 power. Now I can take my derivative. I'm going to put 1/3 in the front. I'm going to put x to the negative 2/3 here. And we're going to go ahead and rewrite this a little bit now. So f prime of x is equal to 1 over 3 x to the positive 2/3. And I'm going to still rewrite this as 1 over 3, and I'm going to change that to a cube root of x squared. Or maybe that exponent, you can put it inside or outside. It doesn't matter. But I'm going to put it outside because actually it's going to be easier if I do. Why is that? Well, I know that because of practice. With you, it's a trial and error thing. All right, so there's my derivative. So now I want to figure out what is f prime of 8. So that's going to be 1 over 3 cube root of 8 squared. Well, the cube root of 8 is 2. 2 squared is 4, and 3 times 4 is 12. And so that should be our final answer on that one. Let's go ahead and see if I did it right. Should be one of our answers there, hopefully. There it is, 1/12. Okay, number 37. Lost it. Bring it back here. Having some technical difficulties. Okay. All right, so on this particular problem, the number I'm plugging in is e. The function that we're finding the derivative of is ln of x. The derivative of ln of x is 1 over x. And therefore, this thing, which is equal to f prime of e, would be 1 over e. Continuing on, number 38. Darn it. Okay. So, what's going on with this guy? Now, this does not look like a difference quotient to me. I don't see my x plus h there, although maybe it is. Maybe it is. Maybe this is the alternative form of the definition of a derivative. It is, actually. I just realized that. So all the last problems that we were looking at had this form. This one has this form instead. Now, how do I know? This one's a little bit tricky to notice this with, by the way. But how do I know that's what it is? Well, I know that this is f of c, and I know this is my c in that form, right? So if I plug in c, if I plug in 0, cosine of 0 is 1. So this is f of c, and this is f of x. Now in the bottom it says x minus c, right? But what is x minus 0? Well, it's just x, so they didn't bother writing the 0. So this is actually the alternative form of the definition of a derivative, okay? So my c value in this case is the 0. My function in this case is that guy. The derivative of that is negative sine x. And so f prime of 0 would be negative sine of 0, which is just 0. So there's our answer. Okay. Now let's just say that you didn't notice that, though. There's another way you could have done this. When it comes to doing limits, you know, the first thing we always try to do is direct substitution. So if you do direct substitution, you get 1 minus 1 over 0, which is 0 over 0. Now, we don't want to write equals 0 over 0. I'll just put an arrow here. And that's an indeterminate form. Therefore, by L'Hopital's rule, this limit, as x approaches 0 of cosine x minus 1 over x, is equal to the limit as x approaches 0 of this thing's derivative on the top and bottom. So the derivative of cosine is negative sine x. The derivative of minus 1 is 0. The derivative of x is 1. And then we do direct substitution again, and lo and behold, we get the same answer. So you could have done that using the limit definition of a derivative, the alternative form, or you could have done it using L'Hopital, but either way, the limit, the value that function approaches as x approaches 0 is 0. All right, let's go ahead and proceed onward. What comes after 38? After 38 comes 45 through 50. So let's go ahead and do 45 through 50. Okay. 45. All right, they want the derivative. Now, first of all, I want you guys to notice this is an implicit function. Okay, there's an equation with a y inside. Usually, with an explicit function, the y is outside, but in this case, when it's inside, we call it implicit. And I want you guys to remember when you do an implicit derivative, when you take the derivative of the y, you have to put a y prime in there, right? So here we go. I wonder if they're going to have us use any trig identities here. I hope not. So what we're going to do is we're going to take the derivative of this whole thing with respect to x. And when we're all done doing that, we need to find out what dy dx is. All right, so the derivative of this thing requires a chain rule. The derivative of the outside, which is sine, is just cosine. Easy enough. But the derivative of the inside, which is what I'm going to multiply this thing by now, is a product rule. Okay? So it's going to be the derivative of x times y plus the derivative of y, which is y prime, times x. So notice when you take the derivative of x, it's just 1 like usual. Then we bring down the y. On the other side, where we take the derivative of the y, that would be 1 also, right? But every time you take the derivative of y, it leaves a y prime also. And then the x just comes down as is. So that's our product rule with the little chain rule situation there. All right, so then we need to apply the derivative over here also, so that equals 1. So I've got cosine of xy being multiplied with y plus y prime x. Okay. So what are we going to do here? How are we going to solve for this? I can think of a couple different ways to go about this here. First of all, let's go ahead and distribute the cosine xy in. I don't know if this is going to be the right way to go yet, but we'll see. So cosine xy times y, I'm going to put the y in the front, is y cosine xy. And then cosine xy times y prime x is going to be y prime x cosine xy, all equals 1. The next thing I'm going to do is I'm going to subtract this whole thing over to the opposite side. So if I minus this off this side, it goes away. And if I minus it over here, it'll look like this. And then I want to get y prime by itself. So now I'm going to divide both sides by x cosine xy. I hope my answer's up there. If it's not, that's going to be very sad. But anyway, there it goes. So I've got now y prime is equal to 1 minus y cosine of xy over x times cosine of xy. So the point is that take your derivative. Don't forget that when you take derivatives of y, you get a y prime factor. And after you do that, you get the y prime by itself. Do we see our answer up there anywhere? I don't. And what that means is that either A, I've done it wrong, which I hope I didn't, or B, they're using trig identities. Remember at the beginning I said, oh, I hope they don't use trig identities. But I think they are. Now, as I'm looking up there at my choices, what I see is they have some secants in there. Huh. Well, secants have a pretty interesting relationship with cosine, don't they? They're their inverse. So check this out. Here's my idea I'm going to go with. I'm going to try splitting this up. I'm going to do 1 over this minus that. Okay? So if I do that, well, this just goes away, doesn't it? Now over here, I've got 1 over cosine x, don't I? I'm going to separate these two now. I'm going to think of that as 1 over x times 1 over cosine. Why am I doing this? Because remember, I looked at my answer choices, and I saw that they have secants, and I want to get that cosine by itself, so I have a secant. So that means I've got now 1 over x times secant of xy minus y. Is that up there yet? Grrr, it's not there yet. I still don't see it. Let's keep searching. Let's keep searching. All right. Y prime. So I don't see anything with a 1 over x in front, but I can rewrite that. So now I'm going to rewrite it as secant xy over x minus y. We're getting close. I'm wondering if, no. Let me ponder here for a second. Okay, I found my mistake. You guys ready? When I split these up, I forgot to put the x over here also, which means that when these cross off, it's not just y now it's y over x. And now these two things have a common denominator, right? So now I can write it like this, secant xy minus y over x. And that is one of our answers up there. It's this guy. So darn those algebra and trig things. You know, this book that I use to help you guys prepare, I'm not too sure if the actual AP test gets this wild with how they want you to write your answers. I think this is good, though. I like to review this stuff with you guys, but don't just walk away from it. Struggle with it and see how far you can get, you know. Good skills to build. I know it's challenging and a little bit frustrating, but worth the struggle. All right, let's keep going here. So that was 45. Let's take a look at 46. Okay, so we're finding the limit of a trig function. Now, I taught you guys how to do these, and when I taught you how to do these, pretty much every time we do it, we end up doing L'Hopital. So check it out. I'm going to plug in 0, and plug in 0. I get 0 over 0, which is L'Hopital. I'm just going to abbreviate it LH. So I take the derivative of sine 2x. Derivative of the outside is cosine. Derivative of the inside is 2. Derivative of the bottom is 1. And now we take that limit instead. Plug in 0. 2 times 0 is 0. Cosine of 0 is 1. 2 times 1 is 2 over 1. Final answer, 2. Okay? So, doing limits with trig functions very often is going to be just L'Hopital, just so you know. Here's another one. I think our friend L'Hopital will be making another show. Here we go. So, oh, I lost it. Dang it. All right. So, direct sub here gives me 0 over 0, and there's our friend L'Hopital. So, derivative of the top is cosine, but it's a chain rule, so we also need to do the derivative of the inside, which is 3. Then we do the derivative of the bottom, which is cosine as well, multiplied by the derivative of its inside. And once again, we're finding the limit as x approaches 0 now with this new derivative form. Plug that in. That makes 0 here and here, right? And cosine of 0 is just 1, so we're left with 3/4 as our answer. Okay. Moving along. I feel like we did this problem earlier today. Matter of fact, I'm pretty certain we did this earlier. It looked like this though, right? It's the same thing, it's just that these are reversed, which means that this is going to be the same thing as this, but with an opposite sign in the front, so it changes the signs. And we found the limit of this earlier. Remember how it was 0? So it's a -0, which is just 0. So, I mean, I'm using what I learned from my last problem. But once again, I mean, the main way you would probably end up doing it at this point is you could do L'Hopital again. You could also, you know, after you rewrite it like this, you could do the whole alternative form of the limit definition of a derivative. But that's that. I figured, why not just use what we know to simplify that. All right, let's go ahead and hit up number 49. Okay. When you plug in 0 for tangent, you get 0. Plug in 0 here, you get 0. We're back to L'Hopital. The derivative of tangent is secant squared, and the derivative of the inside is pi. The derivative of the bottom is 1, and we're going to find now the limit of that. So plug in 0. Now, secant of 0. So basically, if I plug in 0, you guys agree that's just going to be 0, right? So how the heck do we find that out? Well, secant squared of 0 is the same thing as 1 over cosine of 0 squared, right? Cosine of 0 is 1, and 1 squared is 1, so the answer is 1. And so this whole thing becomes 1. So you have pi times 1 over 1, which is just pi. All right. If you guys want a cool little shortcut, I mean, you got to be careful with shortcuts because shortcuts are fast, but the problem with shortcuts is they only work in certain circumstances. But I want you guys to notice something about the answers about 46 through 48. Okay? Well, 48 didn't actually is one of the exceptions, but let's go ahead and take a look at 46. The answer was 2, right? Well, there it is. On this one, the answer was 3/4, right? There it is. The answer of tangent is pi, right? There it is. So it's kind of interesting. This one's 2 over 1, 3 over 4, pi over 1. Nice little shortcut if you can catch it. But you got to be careful. Shortcuts don't always apply. But that's actually pretty common for it to turn out that way. All right, let's go ahead and take a look at number 50 here. All right. So on this one, we're going to plug in infinity here. Now that's going to be infinity. We're going to plug in infinity here, and that's going to give me times sine of 1 over infinity. Now 1 over infinity is 0. Sine of 0 is 0, and this is an indeterminate form. Now if you guys did the extra credit videos, we talked about other indeterminate forms. If you didn't do the extra credit videos, the only indeterminate forms you guys know are this and this, and you know for those we use L'Hopital. But in this particular circumstance, this is another indeterminate form, and what we're going to do with these is we apply something which I just call the reciprocal trick. So anytime you have infinity times 0, you're going to do the reciprocal trick. What that means is you're going to take this piece here, the one in the front, and you're going to move it to the bottom, but because you're doing that, you have to make it a reciprocal. Believe it or not, this is the same thing as that. Now, I'm not going to go into the explanation as to why, but they are the same. It's just a basic algebra move. But now, let's go ahead and see what happens since I've done the reciprocal trick. By doing this reciprocal trick, now if I plug in infinity here and here, I get 1 over infinity is 0, and sine of 0 is 0. And this is 1 over infinity, which is also 0. Guess what? Now I can do L'Hopital. You cannot do L'Hopital here, but you can do L'Hopital here. So by rewriting it, I've put myself in a position where I can apply L'Hopital's rule. And that's what I'm going to do. So the derivative of sine is cosine, but I have to do the derivative of the inside. The derivative of the inside is going to be negative 1 over x squared. Now I'll show you why that is in just a second, but for now, just sit tight. Now I also want to find the derivative of the bottom. The derivative of the bottom is negative 2 over x cubed. Okay? Once again, if you should know how to find the derivative of those things. I'm doing it very quickly because once again, I've got a lot of practice. I know how to get those answers pretty quick. You guys might need a little bit more time to find those derivatives, but that's what they are. I can show you after this problem how to do that if you like, but I'm just going to go ahead and proceed with the problem now as usual. Now that I've done that, before I apply the derivative again, I'm going to take this piece that I had in the bottom, and now I'm going to put it back on the top, but when I do, I have to flip it back over. So now I've got the following. I've got limit as x approaches infinity of x cubed over negative 2 multiplied by negative 1 over x times cosine of 1 over x. Okay? Now in this case, this x will cancel out one of these powers here to make it 2. The double negatives also cancel. And so now just continuing to simplify this. Now I've got x squared over 2 times cosine of 1 over x. Now I'm ready to do my direct sub. Okay, so if I do my direct sub, that's going to be infinity over 2, which is just infinity. And over here, plugging in infinity on the bottom, that becomes 0. And cosine of 0 is 1. Infinity times 1 is not indeterminate. Infinity times 1 is infinity. And so there's our answer. Okay. Now, if you guys want to know how did I get these by taking the derivative, I'll show you. The derivative of 1 over x, the first thing you would have to do is you would have to rewrite it as x to the negative 1. Then you multiply the negative 1 to the front and take 1 off of the power, which makes it negative 2, which is negative 1 over x squared. You would do the same thing to find the derivative of this. Okay, so that's that. That's your homework help for the week, and we'll see you guys later.